Hi, let's kick off. It's the allotted time. Hi, I'm Steven Skone. I've been software engineer for the past 20 years now. Before that, I was a paper boy. It's probably not relevant for this talk. Latterly, I've been focusing more on security. And so now I'm just going to present some of my findings here for, what are pets? Well, they're an excuse for me to spend hours on the internet looking at funny pictures of animals, but also it's an acronym for privacy-enhancing technologies, which is an umbrella term for a whole range of differing technologies, which we'll have a look at in a bit. Pet doesn't have to be software or hardware. Well, it can be hardware or software, but it can be other things as well, as we find from this this quote here from this definition from the European Union Agency for Cybersecurity, ENISA. I will just read this through. Hopefully this is the only bit I'll read off any slides. It's pets are systems encompassing technical processes, methods or knowledge to achieve specific privacy or data protection functionality or to protect against risks to privacy of an individual or a group of natural persons. So I think that's cleared that up. So we can probably go home now. Basically, it's not just hardware or software. You can see it's also processes, methods, knowledge. It can be a whole range of things. And also privacy also refers to, if you see there, the individual or group of natural persons. So natural person means you're not a company, and it also means you're not dead. So at the point you're dead, that's your privacy under GDPR anyway, no longer valid. So let's have a look at what pets are. It's useful to think about pets in sort of classify them in two ways. There's hard pets and soft pets. And hard pets doesn't mean hardware. A hard pet means that there should be no or minimal trust placed in third parties to ensure the privacy of the data. And these should be used in situations where third parties can't be trusted, or single third party shouldn't be able to compromise the privacy of a user. These are countered by soft pets, which again doesn't refer to software, but does mean that you have trust in a third party. And they rely on compliance, consent, control and auditing to maintain that trust. So now you all know about pets, hard and soft. I'll quiz you all. Let's answer a few questions. You want to do hands up or shout out? Anyone? Hands up? Yeah, okay. So for the purpose of the video feed, there are probably 300 people here, so it's probably best if you're not all shouting at once. Right, so this is a little game that I've just come up with. I like to call it hard or soft. So I'll introduce some privacy-enhancing technologies, and then you just have to tell me if they're hard or if they're soft. So just have a think about, do they rely on trust for third parties, or do they not need that? Right, so let's look at the first one, transport layer security. Hopefully most people are aware of TLS. Provides secure connections over a network, uses public keys in X509 certificates to establish a shared symmetric secret for communications. So let's test, is it hard or is it soft? So anyone for hard? We've got a few hands, probably 210. Yeah, is it soft? About the same. Well, I'm going to go with soft. And I think it's soft because you rely on a root CA. So you have to rely on a third party to provide that trust, that transmission of the public keys. I presume you've all been through your trust stores, checked them out and assessed all those root CAs to ensure that you're happy with them. Right, let's move on. So this one, differential privacy. And this works by adding noise to the data to effectively hide the response. So a given individual can say, no, that wasn't the response I made, but statistically as a whole, the data is still valid. So it adds noise to the data. Users can plausibly deny their response. So I'll give you an example of this. So if 100 Devoxians are asked a question about whether they like the crab baguettes or not, which they weren't here yesterday, but they're embarrassed to give their answers, then we can use differential privacy to help with that. And it works as a sort of simplified solution. So effectively, if I ask one of you, do you like the crab sandwiches? And I say, if you toss a coin, if it lands tails, then you answer truthfully. If it lands heads, you toss the coin again, and then return either yes for heads or no for tails. And it has the effect of injecting noise into the responses. But overall, the aggregate response is still statistically valid. But any one person can say, no, I didn't like them, or yes, I did. And you can't say whether or not they did. But it does need a privacy budget, because if you keep querying a user, effectively the noise will cancel itself out over time. So hopefully that's answered the question. Is it hard or is it soft? Let's have a hard. Ooh, we've got a few more hands. Oh, I didn't go for soft. But yeah, so soft because you're relying on the privacy budget of the person who set it. Are they adhering to that privacy budget? So I can see there's some dissenting heads wobbling there. We can talk about this offline later. Well, this one, hopefully next one should be less controversial. Let's have a go at this one. Physical cover over a camera. So we've gone for a hardware approach here. Is this hard or is this soft? Is it hard? Yeah, soft. Any softs? Ooh, just a couple there. I've gone with hard for this one because you're not relying on the operating system manufacturer. You're not relying on anyone else apart from yourself to provide that that cover. So let's move on. Here we go. This one, trusted execution environments. So these are mainly provided by the CPU manufacturers. Intel have their own. SGX, AMD have SEV, and ARM have TrustZone. I think AWS have also got one as well that they're now making. But effectively, trusted executions execute code in a secure enclave away from the main CPU and ensure that the code is attested. This means the code you intend to run is actually running in the enclave. It's also running in encrypted memory, so it's not accessible from the main CPU. And is this hard or is it soft? Any guesses? Hard? No? That's good. Soft? Yeah. Yeah, I've gone with soft as well for this. And the reason I've gone for soft for this one is because it relies on keys that have been provided by the hardware manufacturers to sign the code. So you're trusting another third party. If you're running this in the cloud, for instance, you may have shifted your trust from the cloud provider to the CPU manufacturer, but there's still a third party involved there. And this one, bonus question, can you guess what this image is representing? I was struggling with this one. No. Right, homomorphic encryption. I didn't know what else to come up with, which effectively allows computation on encrypted data. So if you've got a server-provided homomorphic encryption service, it's holding an encrypted number 2. You submitted an encrypted operation of +3, and you'll get returned an encrypted response of 5. At no point will the server know what the data was that was originally encrypted, what the operation is, or what the response is. And the keys are managed by the user. If the response gets tampered with by anyone, it will be apparent to the user that the response has been tampered with. So is this hard or is this soft? Hard? Yeah. About half the people there, another 300. Yeah, soft. Yeah, more hards. Yeah, so this is hard because the users are responsible for managing the keys. The server, the third party in this case, doesn't know anything about the data. And then I've added an extra bonus one in. This is K anonymity, which is effectively removing personal identifiers from data. So if you've got a row of data, row in a table, and you can search by, say, first name, surname, and age, and you return back one user, then it has a K anonymity level of 1. It means it's quite easy to find who those people are or that individual is. So K anonymity is basically trying to remove those personal identifiers. So in this scenario, I've got John Smith with an age. I can search for that user, and I could quite easily find what their medical data was. So there's a couple of techniques you can use to make things to increase the K anonymity. So you can say that more rows will be returned for a given query. You can either, in this scenario, just remove the first name, surname, and then turn the age from a date into just an integer. So now should just return all the people who are 52 with that medical data. You could go even further and change the age to a range, say 0 to 18, 19 to 30, that type of thing, to increase the K anonymity level even more. So, is this hard or is this soft? The data's gone. I can pass it off to a third party for processing. Yeah, deleted it, reduce the granularity. Is it hard? Couple, is it soft? Yeah, probably equal splits there. I think, I don't know, in and of itself, perhaps this data set doesn't contain the data. You can't necessarily recover it from here. But if you then pass it off to a third party for processing, they can then augment that with other data sets and potentially get back to who the identifying person was. So I mean, certainly places like in the UK, it's an offence to knowingly or reckless re-identify people from de-identified data, which suggests to me that although that data set is fine, with other data sets, it perhaps wouldn't be, and you could get back to other people. So could be hard or soft, I just don't know. Right, so yeah, and there was talk just before this one on synthetic data sets, which obviously contain no privacy data. So you can maybe catch up with that one on YouTube. But why do we care? Why would we want to use pets? Well, obviously to enhance privacy, but you need to, for who, yourself, your users, and what are you actually trying to protect? Are you trying to protect medical records, shopping habits, browsing history? It all depends what you're trying to protect as to what sort of pets, or even if you'd want to use them. And as I say, basically it all depends on your use cases and your organisation skill sets as well. What skill levels do they have to implement some of these things? So I promised in the little blurb about this that you'd get a chance to amaze your friends. So here's some amazing things that you can amaze your friends with by not getting a GDPR fine. If you implement these pets, then you can mitigate or reduce your chance of getting a fine. Sleep easily at night, because you know that when you get hacked, and it's a when rather than an if, your blast radius will be reduced. And obviously users will flock to your service when they hear about these wonderful pets that you're using. I mean, the likes of Apple are starting to try to use privacy as a differentiating factor, but it's not necessarily going to bring anyone to your site, so it will be a cost for your software. Right, and I also promise you to be able to astound your enemies. So before you can astound and otherwise thwart your enemies, it's useful to know who your enemies are. Are they nation states, competitors, script kiddies, or cyber criminals? So you need to think about who your enemies are, and obviously there'll be different techniques to mitigate that. So as boring as it may be, it's necessary to conduct an assessment management exercise to identify what data you already hold. You actually need to know what you need to protect. And I think we're running low on time. So yeah, and then you implement appropriate pets to do that. Get started. So it all sounds great. Where do I start? Well, it all depends what your starting position is. Probably you've already got pets there. They add an performance overhead, so it's not a free lunch. They can be complex to implement. So make sure you do your research, have a look at these sites, Anisa, Ada Lovelace Institute, Royal Society. Have a look at Research Individual Pets. And thank you. I've got 3 seconds left, so I'll leave you on that slide. And I've been Steven Skone. You've been a great audience. Thanks very much. Thanks.